Hi, today's lecture video is going to go over 2.3 for Math 150, and we're going to continue talking about linear equations, but today we're going to be looking at linear inequalities and see how we solve them very similar to how we do linear equations, except now instead of having an equal sign, we're going to have less than, greater than, or one of those other options. But we're still pretty much going to work through these in the same way. So I've gone ahead and worked out some of these problems even though we haven't gotten to do them in class yet. So with the linear inequalities, one thing we do need to talk about is how we use symbols for these inequalities. So I have this kind of little handy guide here that goes through some of the ways that you can graph them or represent them in inequality notation. And as you notice here, anytime we have just a greater than or a less than, we're going to use an open circle or we'll use a parenthesis. So a parenthesis and an open circle means you're just using the less than or the greater than. Now if we have a less than or equal to or a greater than and equal to, then we're going to use a filled in circle, because that means it does include that value, or we're going to use a bracket. Okay, so those are kind of the notations that we'll be using. And you can see that here, when they're graphing on a number line, they usually have an open circle or a filled in circle. When I did it, I used the parenthesis or the bracket, but you can do it either way. When you're working on your homework, it'll accept either of those options. So in this example, we're just solving and graphing the solution set. So we have 3x is less than 12. So just like we did with equalities, we want x by itself. So I'm going to divide both sides by 3, and I get x is less than 4. So on my graph right here, I know that 4 is right here, so I want x to be anything less than 4. So that would be down here to the left, right? All these values to the left of 4 are less than 4. So I'm going to put a parenthesis here because 4 is not included, right? I don't have an equal to there. And then you just draw your line here and it would go down forever and ever that way. So you can do that parenthesis. We also could have done an open circle right at 4 and done the same thing. Either one would mean the same thing. When we're writing it out, if we were asked to write it out, like this, then we would have our parenthesis just like we do on our graph here. We would have the parenthesis by the 4, and then the number lines on the ends of the spectrum is always negative infinity over here and infinity over here. So if this doesn't really have an end point, this goes all the way out until negative infinity. So we'd start down here at negative infinity, comma, up to 4. And anytime we use infinity or negative infinity, we're always going to have a parenthesis. It never has a bracket. So it will always have the parenthesis beside a infinity or negative infinity. And you can see that on some of these examples here. All right, here's another example. We've got negative 7x plus 5 is less than or equal to 40. So again, we're trying to get x by itself. So we're going to subtract 5 on both sides. Then we get negative 7x is less than or equal to 35. To get x by itself, we're going to divide by this negative 7. And that gives us negative 5. But one rule that is different from when we're dealing with equalities is that if we divide or multiply by a negative, then we need to flip the inequality sign, which means instead of it saying x is less than or equal to, it now is going to say x is greater than or equal to. So you flip that inequality sign anytime you multiply or divide by a negative. You don't have to do it if you're just subtracting a value, but if you're multiplying or dividing by a negative, you do need to flip the inequality sign when you're going to your final answer. So our final answer here is x is greater than or equal to negative 5. So because we have the equal to part there, we're using a bracket, okay, or we're using a filled in circle, whichever way we chose to show it. And then we're doing greater than, so we're going off to the right all the way up here to infinity, right? So again, here when I'm writing out in this format, I'm going to have my bracket from -5 up to infinity, and we use the parenthesis anytime we're using an infinity. So this should look just like the graph up here, right? I'm starting from -5 up to infinity, bracket, and then parenthesis. All right, now our inequalities could look different. This one is a conjunction where you have a value in the middle and then also on both sides. And something to remember with these type of inequalities is that just like with a equality, an equation, how we have to do the same thing to both sides, this one technically kind of has like 3 sides, right? 3 parts to it. So we have to do the same thing to all 3 parts to keep it equivalent. So we want x by itself in the middle. So you're going to end up with x something, you know, less than or greater than, whatever, and then values on both sides is what we're going to end up with. So we want that x by itself, so we're going to subtract 5 from all 3 parts, okay? So -3 minus 5 gives us -8. This cancels out, right, and we're just left with 2x, and then 7 minus 5 is 2. Then the last thing we need to do to get x by itself is divide by 2. So -8 divided by 2 is -4. 2x divided by 2 is x. And 2 divided by 2 is 1. Okay, so we're left with -4 less than x less than or equal to 1, right? So x is going to be between -4 and 1. The -4, because it doesn't have an equal to here, is going to have our parenthesis, right? And this does have an equal to, so we'll use the bracket. So we'd have -4 up to 1. When we graph it, again, parenthesis on the -4, bracket on the 1, and then just draw the line between it. This example is another conjunction that we're going to work on, but of course, depending on how it's set up, it could be a little more difficult, could take more steps, and this is one of those situations where it takes a few more steps than what we did on that last one. But with all of these, we're always trying to get x by itself in the middle. So we just have to do whatever's necessary to get to that point. Now, when we have fractions, like we talked about in the last lecture video, we usually like to try to get rid of the fractions because it just makes it easier for us to solve. So when we're trying to get rid of fractions, we want to multiply by the least common denominator or the least common multiple. And for 2 and 5, that is 10, right? So 10 is the smallest value that 5 and 2 would multiply to get. So we're going to multiply everything by 10. So that means this part, and this part. So don't forget to multiply all 3 parts by 10. So when I do that, 10 times -1/2 is -5. 10 times this, what I did was 10 divided by 5 is 2. So I just left it here as 2 times 2 minus 3x. So I kind of did this in 2 steps. And then 10 times 1/2 is 5. Then continuing this one, we multiply or distribute in that 2, and we get 4 minus 6x. And so that is our new inequality. So now what we want to do is get the x by itself. So I'm going to start by subtracting the 4, right? So -5 minus 4 is -9. 4 minus 4, that cancels out, and I'm just left with -6x. 5 minus 4 is 1. And then our very last step, now we have x here. I want to divide by -6. So I can cancel that out and be left with just x. So I'll have -9 divided by -6 and 1 divided by -6. All right, so remember, anytime we divide by a negative, we've got to switch those inequalities, right? We've got to turn them around. So this, the less than or equal to, becomes a greater than or equal to. This is a less than, and it becomes a greater than. So now we have 3/2 is greater than or equal to x greater than -1/6. But typically how we're going to read our inequalities is we usually want them to get bigger from left to right. So we're going to have a smaller number on this side and a bigger number on this side. So that means what we want to do is just turn this whole thing around. So we're just flipping it around to rewrite it from smallest to largest. So we're going to have -1/6 is less than, right? Because you see the small part here is by the -1/6, right? The big part is by the x. Then this little part of the one with the equal to sign is by the x, which it is here. And then the 3/2 is over here. So x is going to go from -1/6 up to 3/2, which I have graphed here, again using our parenthesis and then our bracket. Okay, a conjunction is when you have your expression in the middle with the x and you have values on both sides. But a disjunction is where you're talking about the same expression, like here we have the 2x minus 5, but they don't connect. They go in separate directions. So it looks like we have kind of two different inequalities to solve, right? And then we're going to graph them together. So 2x minus 5 is less than or equal to -7. We start that one by adding 5 to both sides. That leaves us with 2x is less than or equal to -2. And then we divide by 2, and we get x is less than or equal to -1. So that's going to be one side of our graph. The other one, we're going to add 5 to both sides again. We get 2x is greater than 6. And then divide by 2, and we get x is greater than 3. So that's going to be the other side. So when we graph this, what you see is that we have these two separate solutions, right? So we've got from -1 down to infinity, and from 3 up to infinity. Again, making sure to use the bracket when we have an equal to sign and the parenthesis when we don't have that equal to sign. So if I'm writing this out like this, we're starting down here at -infinity and going up to -1. So we'd have parenthesis, -infinity, comma, -1, and then the bracket, because that's what we used up here. And then we use this big U looking thing, which means we're creating a union. So it's this or this. So either you're going to have a solution over here, or you're going to have a solution over here. So it's going to be one or the other, but either way it will work if you have something here or if you have something over there. So that's what that big U is, and usually when you're working on that in your homework, it's in one of the toolbox options. It's not just typing in a U. You usually have to like choose that symbol, like you would choose pi or some other symbol to use in your answer. Okay, and then we'll do a few of these with word problems. So inequalities can be used in word problems as well, just like we did with our equations in the last section. So the formula for converting Fahrenheit to Celsius is that formula there. If the Celsius temperatures go from -17 degrees to 22 degrees, what would the Fahrenheit temperatures be? One thing to notice here when it says inclusive there, inclusive means that it includes both of these values, which just means we're going to use the equal to sign here on both sides. So if it didn't say inclusive, then it would mean it's just going up to that point but not actually including those values. But with the inclusive there, that means it is including both of those values. So we're setting this up using the equation they gave us, and we're just doing that inequality where it's from -17 up to 22, and by solving this we are going to find out what the Fahrenheit temperatures would be. So we're going to start by dividing by 5/9. That's going to get rid of the 5/9 here and get it over to both sides. I just left my answer as a decimal. instead of dealing with the fractions. So when you put negative 17 and divide by 5 over 9 in your calculator, you should get negative 30.6. And then on the right, I got 39.6. And the last step is just adding 32 to all three parts. And I get 1.4 up to 71.6. And I wrote it here with the brackets. Either way, you can write your answer either way would be correct. Or even if you graphed it on a number line using filled in circles or using those brackets. All right, and the last one we have here, it's looking at which one would be a better deal. So it says, how many miles should be driven to make Company A a better deal than Company B? So on this one, we do need to figure out what X is going to be. We're trying to figure out how many miles we could drive. So X is going to be the miles because that's the variable that can be changed. For Company A, it's going to cost $140 a day plus 50 cents per mile. We're only renting this for 1 day, so we can think of it as just 140 plus 0.5x, right? So 0.5, so 50 cents per each mile plus that $140 flat fee. Company B is cheaper on the flat fee. It's only $80. But it's more per mile, right? So it's 80 cents per mile. So we want to see when Company A will be a better deal. So if Company A is a better deal, that means it's cheaper, right? Which means it would be less than Company B. So that's how I know which inequality to put here is based on what I'm trying to show. Am I trying to show that something is greater, something is less than? So this one we want to do less than. So we work out this problem like we did the others, and we end up with X is greater than 200. Our inequality sign ended up having to flip in the last step because we divide by a negative. So our conclusion is that if you drive more than 200 miles, Company A will be a better deal. Which would also mean if we drive less than 200 miles, Company B would be a better deal, right? So that would be how we would interpret that outcome. Okay, so that is all for this section. Section 4 doesn't have much in it. Really, we're just looking at some piecewise functions, but I'll save that for another video. And so again, if you have any questions, please feel free to email me. All right, thanks.